Hello, everybody. Good morning, good evening, wherever you are. People are still filtering in a little bit, but we want to get going. I see a pretty big crowd and some familiar names. Thank you very much for joining us while we talked this morning about PulsaPro, some of the innovations, some of the things that can help you do your job easier, faster, safer. So we're going to have a Q&A session, a questions and answer period at the end of this presentation. The chat will be open, but if you want to save your questions to the end, we'll make sure we have time to cover that then. So with that, I will go ahead and turn it over to Jeff Martin.
Okay. Thank you, Jesse. Again, welcome everyone. I'm really glad that you can be with us this morning. I truly appreciate your time is valuable. So I'm hoping that this is going to be a very meaningful presentation for you. Just quickly, our agenda today is going to be going to do a little introduction to Pulsafeeder, and then an introduction specifically to the PulsaPro product line. And then we're going to talk about some key features that are going to, reduce commissioning and startup time. It's going to help you avoid, costly repairs to your system and so forth. We're going to talk about those in a minute, and then we're going to show how these are all culminated in, some real special API and petrochem applications that we're excited to be a part of. And then, as Jesse mentioned, we'll have a Q&A time. So just to kind of whet your appetite a little bit, the things we're going to be talking about, don't worry too much about all the details on here. We're going to go through them in detail, but we're going to be talking about key diagnostic features that are going to help save time in startup and commissioning. They're going to increase your service life, and they're going to reduce your downtime. So we're going to be talking about those key features primarily a little bit later. But first, I want to just introduce myself officially. My name is Jeff Martin. I'm the EPO product manager with Pulsafeeder. I've got 20 years of experience in the process industry. The majority of that is in application engineering. And most recently in 2018, since 2018, I've been the product manager at EPO. So a little bit about Pulsafeeder and our history. So we have the continuous history of improving and building on our pump experience. The hydraulic metering pump was invented in 1942 by a gentleman by the name of Larry Wilson at a company called Lap Corporation. And since then, in the 70s, Lap Corporation became Pulsafeeder. And in the 1970s, the Pulsa series, the first complete series of hydraulic actuated metering pumps, was introduced, called the Pulsa series. Call that our legacy product line. In the 1990s, we introduced the Pulsar pump, an innovative pump in its own way, and we learned a lot through the design and development and installation of that product. And all these things have come together in PulsaPro, most recently introduced in about 2015. It was launched. So we have other product lines. It's not like we didn't do anything in between those years. We've got other product lines, but I wanted to focus specifically on major improvements and major milestones with hydraulically actuated metering pumps. About Pulsafeeder, we've got factories in Rochester and Punta Gorda, Florida, and we've got over 100 global channel partners located throughout North America, Asia, Middle East, and Europe. And with our channel partners and with Pulsafeeder's decades of experience and knowledge and expertise in hydraulically actuated metering pumps, we are experienced and ready to serve you in the oil and gas and petrochem, muni, industrial water and wastewater marketplaces, as well as a general industrial. And just a little side note, we literally, quote unquote, wrote the book. The metering pump handbook was written by Pulsafeeder engineers and product managers and was published in 1984. And it's still out there. You can still find it, but it's just, something we like to bring to folks' attention. So now that you know who we are, I want to introduce you to the PulsaPro, the latest iteration of and culmination of Pulsafeeder engineering expertise and experience. So, PulsaPro metering pumps they handle all types of chemicals, but in general, metering pumps, why metering pumps? They handle the most hazardous, highly corrosive, and explosive and toxic chemicals. They're designed for safety with minimal leak pass and protections for personnel and equipment. They are intended to be used for accurate and precise dosing of chemicals into process streams for water treatment, wastewater treatment. They're counted on when small controlled amounts of chemical need to be supplied accurately, immediately, and proportionately. And they can be controlled either manually or by remote control. And we like to call metering pumps the heart of the system. It's really the lifeblood in a lot of ways of ultimately getting those processes to the final end state that they're intended. So that's generally where PulsaPro metering pumps are and why they're used. The PulsaPro product line in general to date, we've got 3 models ranging in capacity all the way up to 243 gallons per hour and a maximum discharge pressure of 3,100 psig, and the liquid temperature range of 250, max viscosity up to 3,000. And this, in combination with the fact that it's a hydraulically actuated metering pump, it's a non-loss motion. All these models are full sinusoidal stroke motion and a compact footprint. They provide 0 to 100% capacity, 10 to 1 linear flow adjustment, and a super high accuracy of plus or minus 0.5% standalone accuracy. So, it's situated to provide just virtually any chemical dosing opportunity and work in any application. And the PulsaPro, we're going to get into a little bit. It's a culmination of, like I mentioned, years of expertise. So, it includes the diagnostic windows, leak detection, etc. I just want to give a little bit of commentary on how how the PulsaPro operates for those of you who may not be familiar with metering pumps. We essentially take a rotating motion of a motor and it's reduced in speed, and the power is transferred to a reciprocating piston that's sitting in a bath of hydraulic oil. At that point, the diaphragm here will follow the hydraulic fluid back and forth, left and right, if you will. And on the suction stroke, or in the left-hand direction, it will fluid will be drawn into the reagent head, and then on the discharge stroke, the check valves on the inlet will close, and the check valves on the outlet will open, and therefore, as the piston reciprocates back and forth, flow will be of chemical will be provided through the reagent head. So you can see that there's a lot of intricate components in there. The PulsaPro metering pump is a precisely engineered product built for accurate and controlled chemical delivery. We're also, the PulsaPro is also used in many applications. We call it one solution for many applications. It's used in industrial oil and gas, petrochem, municipal and industrial water and wastewater. It's provided in materials of construction for a wide range of chemicals. On the right-hand side pump there, you can see a metal-headed pump that's available in 316, alloy 20, alloy C, and others. We've done custom engineering depending on whatever the application is. As far as plastic wet ends, they're available in Kynar and PVC, polypropylene, glass-filled Teflon, and then diaphragms, PTFE, Hypalon, and Viton. I mentioned those materials of construction because those are the ones that are the reagent head. There is the only part of the pump that is in contact with your process fluid. So these materials of construction will apply to those wet end, we call it the wet end of the pump. So we've got decades. You might look at this list and it's like, what material construction do I use? Don't worry, we've got decades of experience to help you identify the best material for your application. That's what we do all day, every day. Help you identify the best what the best solution is for your application. So we've done a real general quick overview of why metering pumps are best suited for controlled delivery for a wide range of chemicals, and what PulsaPro is in terms of metering pumps. So I want to take a look at just a few unique features that will help you reduce time for startup and commissioning, and is going to increase service life and reduce downtime. So there's a lot of components to the PulsaPro, and we're going to be specifically looking at and discussing each one of these that are in green here: the push to purge button in the diagnostic window, the hypo valve, the hydraulic bypass valve, the pulse alarm diaphragm leak detection. Those are the external features, but I want to also identify some other key components on the product. This is a 3-component check valve assembly that's supported and installed with a 4-bolt tie bar system that's very rigid. You can see here, this is a stroke length adjustment mechanism. This is a manual version of that. And then over here on the right is what we refer to as the XAE controller, which is an automatic electric stroke controller with a ton of features on it. We have a whole webinar based on that all by itself. And it's fitted with C-face motor adapter. That's the standard mode of input for this product line, and it makes it very simple for installation, removal, changing motor, servicing motor. There's no couplings to the line or anything like that. And then we'll talk about, so this is your gearbox is here, and then you have a pump head and then the reagent head. But primarily, we're going to be focusing on these major external components, the bypass valve, the push to purge, etc. It's going to make your job easier and faster. And we could spend a whole webinar talking about the internals of the pump, but we're just going to focus on a few key internal features that will provide increased reliability, increase your mean time between failures. But just again, to give you the lay of the land here, this is the pump head assembly. This is the piston assembly here. The pump head is where the oil is added, hydraulic oil is added, and then this is called the pump head here. And this is where all the meat and potatoes are for controlling the hydraulics on the right side of the diaphragm, if you will. And then over here, this is called the reagent head with the inlet and outlet. These are the outlet check valve assemblies, which is in contact with your process fluid. So, but we're going to talk about the high performance valve that's buried inside here. and the hydraulic makeup valve that's also works in conjunction with the high performance valve, or the hydraulic performance valve, I should say, to make sure that your diaphragm lasts as long as possible, and it helps maintain solid hydraulics. So let's get into each one of these individually in more detail. So the push to purge valve and the diagnostic window, I mentioned that you may have heard me talk about solid hydraulics, but what's really important, super important, is that the hydraulics are solid, that there's no air in the hydraulic side. When I say hydraulic side, I'm talking about that area of the pump that provides the hydraulic fluid that drives this diaphragm forward and gives that process flow on the reagent head side, but the hydraulics. So think of hydraulics as similar to your brake line, if you will. As you push on your brake pedal, you want to be able to get immediate response out of your brakes. And if you've ever experienced a squishy, or you've got to pump your brake multiple times in order to get it to operate, it's because there's air in the line, or it's not solid hydraulics. So it's really important to purge the air from the hydraulic side of the pump, in order to make sure that on every stroke of the pump, this diaphragm is doing exactly what we want it to do. So when you start up a pump, you're commissioning, or you've just done some service, the PulsaPro can automate this valve. The push to purge valve will operate automatically, but in many cases, not just with PulsaPro, but with just about any hydraulically actuated pump, depending on the configuration, that automatic priming can take a lot of time. It can take up to 30 or 60 minutes, or even longer in some situations. So what the push to purge button does is it allows that system to be manually purged. It's a button that you literally depress, and it allows hydraulic fluid, a large amount of hydraulic fluid, to pass out and get out of that that area behind the diaphragm that is the motive force. So the push to purge, it's an innovative design that's only available on PulsaPro, and it allows for quick identification of whether or not the hydraulic fluid is operating as expected. So this also means that there's no special tools required. In predecessors, remember the slide I showed, the Pulsar series and the Pulsar line. Those pumps actually, in order to do some priming, in some cases, technicians would actually have to carry you might be familiar with a turkey baster, or a large syringe, in order to literally open a port on the pump and inject hydraulic fluid in there to kind of quickly get the priming process completed. And well, you'll be happy to know that there's no special tools required with the PulsaPro and the push to purge button. You don't need a turkey baster in your toolbox. And another unique feature with the push to purge button is the diagnostic window that's adjacent to it. What this does is it gives the operator immediate insight into the condition of the hydraulics inside the pump. This pulsating that you see right there should be what you would witness in a normally operating pump that's fully primed. The full video of this literally shows that it's an empty window there, and that means that the pump is still in the process of priming. Or if you see the oil with some bubbles in there, it's still in the process of priming. But if it's solid, that means the pump is effectively primed. And like I mentioned, with the push to purge, it greatly minimizes that priming cycle. Everybody's busy, and everyone's got probably a lot better things than to just better use of their time. So the push to purge feature really helps reduce the amount of work required for startup and troubleshooting. The hydraulic bypass valve, that is used for protection of the pump. I want to really emphasize it protects the pump from system overpressurization. It not only protects that front end of the pump, which is where the hydraulics are, but it also protects the gear train. And so with that being said, that means that you have increased life of the pump. You have protection in the event of a system upset, and it helps you evaluate the condition of the pump while it's operating. So with the PulsaPro, it's the hydraulic bypass valve is actually external to the pump. And why is that important for you? It's because in other versions of pumps and even our older versions, that hydraulic bypass valve was down inside the hydraulic fluid of the pump. You would literally need to take the cover off and stick your hands down in the oil in order to adjust that. So with it being on the outside, it increases the safety for your operators, and it allows for a much quicker adjustment when you're commissioning and starting up this pump for your unique application. And just by virtue, and what it does is it causes fluid to recirculate, hydraulic fluid to recirculate inside the pump, so that it protects itself from damage in the gear trains and in the hydraulic system. And that means that for you, that if there's some type of unexpected shutoff, someone shuts off the discharge line or operator error or system breakdown, you know that your piece of equipment is going to be protected, and it's going to save you unnecessary downtime. You can see the video in there that's operating there. Also, normally when you walk up to the pump, we've had some of our field personnel and actually some of our customers say that this is one of the most unique and innovative features on the market. Not many other pump manufacturers have this, but this gives you insight into your pump operation. If you don't, under normal operating conditions with this properly set, as you can see in that little video clip there, there's no oil present until it goes into upset condition. So when you're troubleshooting, if you have a system problem, this gives you a real quick indication into the insight of whether or not this pump is the problem or I need to look someplace else. So it saves you time and troubleshooting and evaluating system status. So that diagnostic window is a key element that eliminates guesswork and saves you time. So just really want to emphasize, this protects the pump, and that every system should have an external pressure relief valve in its line, so you protect your system. Need to put that out there. But the hydraulic bypass valve protects your pump, and more importantly, your personnel with safety, and gives them further insight into the pump condition. So we don't want no more operators sticking their hands down inside of oily reciprocating pumps to try and adjust them and set them up. That's eliminated with the PulsaPro hydraulic bypass valve in its diagnostics window. The hydraulic performance valve and the hydraulic makeup valve, these protect from system upsets. These maximize your diaphragm life for a long mean time between failure. So, if your pump goes down, if your diaphragm fails for some reason, hopefully you've got a spare diaphragm on part and on hand, and you've got the expertise to deal with that. But with the PulsaPro, we've taken great efforts to minimize and that potentially happening, and also increase the life cycle of the diaphragm. So what does this do? So it's located just behind the diaphragm, internal to the pump. And with each stroke of the pump, the diaphragm, if it comes in contact with that, the pump automatically fills that cavity behind the diaphragm to make sure the hydraulics are firm and hard on either side of that diaphragm. So you want chemical here, this needs to be fully primed here. And when this is fully primed, this diaphragm literally does no work. It just floats back and forth between here. And the hydraulic makeup valve helps to ensure that there's solid hydraulics on that side there. It keeps the system in balance. So what does that mean for you? That means that this protects your diaphragm and your pump. It means that in the event of a closed suction condition, maybe someone's closed a valve downstream, that these critical components of your pump the likelihood that they're going to fail is significantly reduced. That diaphragm can last for millions of cycles, but if there's an error or someone does something, the diaphragm can be damaged. And so we want to make sure that for our customers that downtime because of this kind of problem and maintenance costs are minimized when there's an accidental blockage in the suction side of the pump. So this also ensures that the diaphragm is balanced, and it's going to, in some cases, operate for millions of cycles before failure. So your pump will stay running, and there'll be minimum downtime, and it will. This should be something you don't need to worry about in your system. The hypo valve, the auto degassing valve, we've talked a lot about the hydraulic side of the pump. This has more to do with affecting the process side of the diaphragm. You recall that we've been talking about these features that make your pump efficient, improve mean time between failure, and avoid downtime. This also is a feature that if your pump is primarily used for fluids that can lose they off gas, in particular sodium hypochlorite. This at room temperature, it vaporizes, it builds up gas inside the lines, system lines, and in particular the pumps here. And we get into that situation where we don't have those solid hydraulics because there's gas in the line. So this means that for you, the customer, that it's possible that once air builds up on that process side, that your pump is literally working inefficiently using electrical power and not providing and delivering any chemical. Or it's got to operate faster because it's being inefficient and it's not pumping efficiently. And so that means higher costs. That means more electrical usage, and we know how sensitive and important that is these days to be energy conscious. So what does a hypo valve, auto degassing valve do? It's automatically programmed to take that gas and take that fluid and recycle it back into the reagent head. And meanwhile, the off gas is automatically eliminated. Some pumps need to, if we don't purge this, if it's not taken care of on a regular basis, conventional pumps can run for extended periods of time in order to completely remove the air and return to performance. Or in worst case, they become airbound and they completely fail to pump any fluid. That means your operator's got to go out there. They've got to, first of all, diagnose what the problem is. They've got to prime that pump head and get the pump working. This means that not only your pump could be inefficient, wasting energy, but you're wasting, people are spending time doing things that they shouldn't have to otherwise worry about. So inefficiency will affect the pump and operator time. So this is the hypovalve auto degassing valve. And then the last unique feature we want to talk about in terms of pulse alarm and safety and you know, reducing mean time between failure, increasing safety, and being efficient is the pulse alarm diaphragm leak detection. Typically, diaphragms internally fail because of some sudden and unexpected change in the system, which might be, you know, maybe during startup, you know, maybe a new facility, a new system is installed, and you know, if there's debris in the line, or maybe there's solids in there, those can wear the diaphragm out prematurely quickly. Or if the process fluid becomes contaminated, this can lead to unexpected diaphragm failure. So the pulse alarm diaphragm leak detection is a sandwich diaphragm that monitors the pressure between the two diaphragms, and if the one diaphragm fails, immediately the pressure changes and a signal is sent either to, you know, your SCADA system, or it can trigger an alarm, but there will be some type of visual or digital indication of diaphragm failure. And so what does this mean? How does this help you? Well, this means that your pump is protected, and therefore, you know, increased uptime, you know, increased mean time between failures, more service life, saving you costly downtime repairs on a pump can be avoided. But also, conversely, hydraulic fluid would be minimized by, well, the contamination of your process system will be minimized from hydraulic fluid entering into the process stream. So it protects the pump, it protects the system from any unexpected diaphragm failures. And so this is an important feature that's available on PulsaPro, and it will help eliminate any downtime. So we've talked about features of PulsaPro that will reduce time for startup and commissioning, increase safety. But with these things in mind, another great feature of PulsaPro is that it's fully API compliant, and that with Pulsafeeder assistance and experience, we can help address some of the most difficult applications you might have. So with all those things in mind, we're suited to be a great solution to your API and petrochem application. First off, PulsaPro is fully compliant with API 3rd edition. That means it's available to meet all those requirements, so that it simplifies your system design. When you design a system to this standard, you know that you've got a system that you can be confident in, and it's going to, you know, by meeting certain standards, you know that quality products are being put together for one complete system. So we can supply these pumps with API features and capacities. Many of you may not know that capacity is increased by 10%, and pressure ratings are increased by 10%, just to provide an additional safe margin of safety. We can provide all the hardware that's required, special flange connections, shipping preparation, etc., to be compliant with that. But also, our facility is set up to do all those standard tests, and even many of those optional tests that are required to meet API. Repeatability and linearity, mechanical run tests, sound level tests, positive material identification. We're equipped and ready to provide those services. We already do the standard hydro test and steady state accuracy tests that are required by API as a standard. And you know, we as a factory have provided for decades pumps in compliance with this that have all the documentation and literature ready to make sure that everything's at your fingertips in order to troubleshoot, evaluate, and make sure that this pump is the right pump for your system. So API compliant means that, you know, we're helping to make your system design easier by providing equipment in compliance with this, and that you can be confident in Pulsafeeder as a manufacturer that we're providing quality products. The one of my favorite challenging applications is a chemical called teal, or triethyl aluminum, that's used in the manufacture of polyethylenes and polypropylene plastics. And not just because of that, but it's interesting to talk about, but it also speaks to PulsaPro's ability to handle hazardous chemicals. Just a little bit about teal. It's considered a pyrophoric chemical that is flammable when it comes in contact with oxygen or just air. So it needs to be completely isolated. And you can just do some YouTube Googling and see and look up teal, and you'll see some pretty interesting videos about that it cannot be extinguished with water. In fact, water just makes it more flammable. So it's a fascinating chemical used in the manufacture of plastics. But again, you know, because of its hazardous nature, because of its dangerous features, it's ideal for the culmination of Pulsafeeder and PulsaPro in terms of our expertise in handling these types of chemicals and being able to provide equipment that takes all these safety features into consideration. We provide reagent heads and check valve designs to ensure 100% leak-free assembly, fittings, and purge mechanisms in order to accommodate nitrogen gas in and around that pump, so that we minimize and completely eliminate the possibility of a fire starting and protecting personnel. So this is a perfect example of all the features we've talked about for saving time, improving safety, minimizing downtime, increasing mean time between failure. This is all coming together in a single application. So maybe you don't have a pyrophoric teal application, but you know, we're here ready to help you engineer and be a significant partner in designing for just about any application you might think of. So let's just take a moment to summarize where we've been, and then we'll open things up to a few questions if you have any. But again, we covered these main components that are essential to help you, the customer, save money, save time, and increase safety. The push to purge valve, the hydraulic bypass valve, the hydraulic performance valve, all these components together are going to, increase your efficiency, give the operator and you insights directly, literally seeing into the pump, how it's operating. It's going to protect your pump and your system. It's going to help you be more efficient, save energy costs, save on time for startup and commissioning. It's going to help you make sure that your system is protected and your capital investment is protected in these pumps from unexpected system problems. And also, I want you to know that you can count on Pulsafeeder. We're proud that in these days of long lead times and missing products on the shelves, that we're proud to boast of a 95% on-time delivery despite the current global supply environment. We've got over 75 years of innovative and quality metering pump applications, installations, and so we're ready to help solve your problems. And we have a network of channel partners and that are professional, and in some cases, many cases, know our products better than ourselves, having they do the installation and they do the startups, and they know the customer. They know the customer's applications inside and out. So we have a great system of support, and we want our customers to be successful. So let us be a partner with you on that. And we have experience in worldwide in doing API 675 applications, and most recently with PulsaPro being used in custom solutions for the most challenging applications. So you don't have to go it alone. You can let Pulsafeeder and our channel partner teams, we're ready to help provide engineered solutions for hazardous and your most challenging applications. So with that, please visit our website to find a representative near you and learn more about Pulsafeeder, or you can feel free to contact me with any questions you may have, Jeff Martin, jsmartin@idexcorp.com. I think my email's in the invite also for the webinar. But if you have any questions now, you can use the question feature in the webinar and type them in. We'll do our best to answer them. And if we can't, we'll get back to you as soon as possible. But, please take this time to ask a few questions. And if you had to go, then we thank you for joining. So thank you for your time.
Thank you, Jeff. In the webinar panel, in the control panel, you can see the chat. You can put the questions in chat. There's also a question section. You can put it in there. Jeff, we do have some from LinkedIn comments and a couple of questions that were submitted prior. So I'll just give a second for anybody to put any questions in the chat that you like. We'll start off with some of these. So Jeff, the first one is in the event of a blockage of suction, I think is what they're talking about. How long can the HPV operate to protect the pump?
The hydraulic bypass valve, it will operate. It's kind of dependent on the system conditions, the pressures that are involved, etc. I can tell you that if it goes on for an extended period of time, that hydraulic fluid will become entrained with gas again, so it can operate in that state for some time. As long as there's hydraulics in there, it'll be fine for a long period of time. But it will also take, once that system is recovered, it'll take about 3 to 5 minutes for the pump to fully recover. So I don't have a real exact answer on how long the pump can operate, but I will be glad to look into that and get back to you.
Okay, thank you, Jeff. We had another one from LinkedIn, and it says, I understand, so this might just be a clarification question, Jeff. I understand that the bypass condition window can be used to check if HPV, hydraulic bypass valve, is operating each stroke, which will reduce the pump flow rate. Kindly confirm.
Yeah, I read that beforehand. I saw that, and it sounds like we got two different things being referred to in there. So the window for the hydraulic bypass valve, you should not normally see any oil in there at all. You would only want to see oil in there when it's bypassing, which means you have a system upset situation. On the other hand, on the top of the pump, you have the push to purge valve and its diagnostic window. And in that case, you would see, under normal operation, you want to see oil pulsating inside that window. So hydraulic bypass, you don't want to see anything, and if you do, you got a problem. In the push to purge and its diagnostic window, you want to see it, and you want to see it nice, clear, honey-colored oil in there without any oil in it. So
worth mentioning, Jeff, that in the event of a system issue and you're troubleshooting, trying to find out where the problem might be, having that insight into the hydraulic bypass condition of the valve or of the pump can be very useful in trying to figure out where that problem is.
Right. Yeah. So you can identify, number one, if it's your pump or your system. So if you're bypassing, then it's your pump, and you need Well, if you're bypassing, then there's your pump is either not set correctly, you've had a system change, or there's some type of blockage downstream.
Okay. Thank you, Jeff. Another question came in. Please explain how the HBV and makeup valve work in conjunction.
Okay. How can you repeat that? I'm sorry. How the HBV
and makeup valve work in conjunction. Just reading it verbatim.
Okay. So the hydraulic makeup valve works in conjunction with the push to purge. I'm sorry, with I'm sorry. The makeup valve works in conjunction with the hydraulic performance valve inside the pump. So what that does, you're right. I don't think I touched on that. Even I pointed to it. So thanks for bringing that to my attention. So the hydraulic makeup valve actually, as that hydraulic performance valve injects hydraulic fluid behind the diaphragm, the makeup valve will open and allow fresh hydraulic fluid to come in from that pump head reservoir and fill that void behind the diaphragm. So they really work in conjunction with one another. Every time that hydraulic performance valve is activated, the hydraulic makeup valve also is working to allow fluid to come in if it's needed behind that diaphragm.
Great. And I see another question here. Will this recorded presentation be posted on pulsa.net for future reference? I believe, Jeff, you plan on sending it out to everybody?
Yeah, this is being recorded, so it will be available, and probably likely on pulsa.net or possibly on our YouTube channel. But it will be made available, and it will be available to the attendees for sure.
Yep, I think it's a good idea for our partners. We can put it on pulsa.net.
Sure. Yeah.
All right. Any other questions? I'll give 30 seconds longer to see if anything else comes in. But thank you very much, everybody, for joining. We had over 100 people here at one point, so really great turnout. Thank you, everybody, for joining.
Mm-hmm. I agree. Thank you very much for your time. I appreciate your attention. And again, if you have any questions or comments, please feel free to reach out to me or our channel partners, or just contact us. Thank you.
All right. So everybody, have a great day. Have a great night, depending on where you are. And thanks again.
Thank you, everyone. Have a great day.